Hello and welcome. In this video, we're going to take another look at our current P5, the one that focuses on the geometric properties of certain cross-sectional areas. And specifically, we are going to take a look at how to print our results to a file. Now, this video assumes a number of things that you've been following along with this series of projects, specifically that you have worked on your P3 modified, and that you also have a copy of the current P5 instructions as well as the P5 sample. Now, before we get started, we want to take a look at the P5 sample as well as the instructions to understand what is different about this table. In the earlier video, I showed you how to use printf to display the results in this nice tabular form, again, with each of the values separated by commas. However, though, if you notice in this table, in addition to having the column headers and this nice border, we also have all of the radii on one row, all of the edge values on one row, all of the areas on one row, and so on. Now, if you take a look at the instructions, you'll note that we have a second output. In this case, this output does not go to the console, but rather it goes to a file. And the intention is this is a little more persistent. In other words, it can be used later on, stored on the file system, sent to somebody in an email, used by another application, etc. And you'll notice here specifically that the pattern or the way that we want to display the data is a little bit different. And you'll see here that I have specified that we want to have one of each value on a row. In other words, a row will correspond to the iteration of the calculation. In other words, for the first radii, and have the edge, area, ix, iy, and iz. The other thing to note along these lines is we will not have any sort of column headers, nor will we have a border in this particular example. This file is meant to hold only the data, none of the metadata. In other words, none of the information about the columns themselves. So essentially all we're going to have is a bunch of numbers separated by commas. The other thing to point out before we leave this file is that we are going to hard code the value for the file name. And the file name in this case will match the function name. And we are going to add on the .csv file extension for comma separated values. So let's go ahead and get started. We might make some notes as we go along. We can keep the P5 instructions up for a little bit of guidance. But if we come down here into the true branch of our if statement, in other words, where our results from the calculations were in fact successful, basically it means that we have populated our individual parallel vectors, the radii, the edge, the area, ix, iy, iz. Then we saw how we could print the table using a series of for loops. Now what we want to do is we want to do the same thing, but we want to print it to a file. And so we're going to go through the basic recipe again for printing to a file. The first step, of course, is that we have to have a way to open the file. So we are going to need to add an extra variable for a file pointer. So we'll come up here to the top and basically add this as a file pointer. We're going to call it output since we are going to be, of course, writing the output to a file. And down here, then what we want to do is we want to attempt to open the file using our fopen. And again, we're going to hard code the file name. And you can come over here to the instructions and you can simply just copy and paste it in. We'll work later to see how we can make this file name also a variable. But we want to open this file now for writing. And so this will always be your first step here, is to have the file pointer and attempt to open the file. The second step will be that we check to see whether or not we were successful at opening the file. So what we want to do is we now want to check the file pointer. And why would we need to do this? Well, it turns out that it is possible that you were unable to open the file. And there's a number of reasons that this could happen. Perhaps the file is opened by another application. Perhaps you're attempting to write somewhere that you do not have access to. Or in the case of network applications, perhaps you have lost connection to that network drive. But nonetheless, we still need to check to see that our output file pointer is equal to null, or if you want to look at it the other way, we want to make sure that it is not equal to null. And if it is equal to null, we need to let the user know there was a problem. And in this case, error failed to open output file. And again, just make a nice friendly message to the user. We can discuss a little bit about what this does to our exit success for our application. For right now, we're not going to adjust the results in our main. We'll just let the main return exit success. But under the else branch, then what we want to do is we want to assume now that we were successful in opening the file. And before we forget, because it is very easy to do so, as our third step, we simply want to remember to close the file. And that's probably the most common thing that you're going to forget with respect to file I/O, is to remember to close the file, and you can unintentionally leave your file hung. And particularly if you are trying to open a file multiple times, can cause some issues in your application. And so the third step will always be to remember somewhere to close the file. Now, inside of this branch of our if else, once we have successfully opened the file, now what we want to do is we want to start printing the results to the file. And now we go back one more time. I want to take a look at the format that I'm interested in. And specifically, in this case, I'm going to have 6 columns. I want to store each of the values for the parallel arrays in their own column, separated by commas, and then a new line after the last column. And so we'll go ahead and copy this over and put this in our comments just for a guide. And then what we'll do is we'll set up a for loop that will allow for us to loop through each of our parallel arrays. Again, what we're going to do is we're going to start off at index equals to 0. We're going to continue until n, and we will simply increment our index. And now what we will do is we will print each of the values in the parallel arrays, each from one at a time from each of those parallel arrays, meaning that we're going to print the 0th index of the radii, the 0th index of the edge, 0th index of the area, and so on, or 0th element, rather, of each one of those arrays. Now, I'm going to do this 2 different ways. You actually need to pick one or the other. It doesn't really matter which one you pick. I'm going to start off doing this all in one line. And so we're going to use our fprintf. We're going to print to our output file pointer. And we're going to create now the format spec all in one go. And remember earlier that we use our %.4f. So %.4f. And we want to separate each of the values by a comma. And fortunately for our case here, we actually have all double values, and we want to keep the format spec consistent. So we're actually going to have 5 more copies of the %.4f. And again, we could use %8.4f. Just, it doesn't really matter as long as we stay consistent here. So 2, 3, 4, 5, and then 6. And then ultimately, we want to make sure that that last %.4f gets a new line. Now, in each of these placeholders, then we want to put one of the values from each of our parallel arrays, starting with the radii. And so in this case, it's going to be radii square brackets index for that first value, or that first %.4f. For the second one, then it is going to be the edge. And in this case, it's also going to be index, area, index, and then we're going to proceed then to our ix, our iy, and then lastly our iz. Now, that's one way to go about doing it. You could argue that's a little messy. It's hard to line up the individual values. So let me show you an alternate way. And you just want to pick one or the other. Again, it doesn't really matter too much which one you pick. And then what we'll do is we will simply make individual calls to our fprintf with each of the format specs. So in other words, in this case, %.4f, followed by the comma. And then what we'll do is we'll use the first parallel array. And that's it. And notice here, I have no new line or anything like that. And what I'll do is I'll follow this up with a second call to our fprintf, again with our %.4f rather. And again, followed by a comma. And then I'm simply going to use then my edge parallel vector, or my edge vector. And at this point, I'm pretty sure you've seen the pattern now. So we'll do this for the third column, the fourth column, the fifth column, and the sixth column. And of course, we'll change which vector we are accessing. So in other words, the area, the IX, and the IY, and then lastly, the IZ. Now, the other thing that we want to change is we want to remember that that very last column gets a new line instead of a comma. Now, again, which one of these two approaches you pick does not really matter to me. There in some cases might be a slight performance advantage to doing it all as one fprintf, but that would be marginal. For right now, focus on which one of these two approaches makes the most sense to you. Fundamentally, they do the exact same thing. And so what I'm going to do is I'm simply going to comment out this second approach. I'll leave that for you to decide which one you want to keep. And then at this point, we should be ready to test our application, provided that we don't have any mistakes. And so we successfully compile. We can now come out here to our command window. We'll do a dir first to show you that there are no tricks going on. There is our p5.exe. Let's remind ourselves of how it works. We are going to use, in this case, the interactive mode. We're going to be prompted for the maximum radius, followed by the minimum radius, and then the number of elements that we wish to test. In this case, it's going to be 5 of them. And then you'll see that I now have a file called circle2dv4. And so if we take a look at that circle2dv4, if you double click on it, it'll open in Excel. You can also drag it into NetBeans, but you see that you have essentially the same values that you had when you printed it out to the console. The difference being is the orientation is different and the column headers are also not provided. Additionally, I'm also going from the minimum value to the maximum value. Now notice I didn't specify that in the CSV file format. So whether you do it in ascending or descending does not really matter to me. It would just be a matter of essentially turning those indexes around. And so you'll see here that the first column has the radii, the second column has the edges, the third is the areas, the IXs, the IYs, and lastly, the IZs. And again, you can see here that we'll focus here on the IZ, then that you can see those values again in ascending order, whereas on the output table to the console, it was in descending order. Now, let's go back to our P5 real quick to the source file, and let's go ahead and make a copy of this now over to our parametric version. So remember now, this is for the interactive, and we want to do the same thing for the parametric. And again, we need to make sure, I think I may have accidentally missed one of my curly braces here. Let me go back up here one more time. So there's my output. Or actually, I think I probably went a little too far. That looks right now. Let's come back down here. And then we'll simply then paste this in here. And there's no point in having this comment block in twice. I'm going to clean up this code a little bit. At this point, we can build it one more time. We can come out to our console and we can simply check to see if for instance, this works for our parametric mode. I'm going to do this one a little bit differently. I'm going to go from 1 to, let's say, 0.5. And this time around, I'm actually going to ask for 10 values. Our table gets bigger. That looks promising. And then also, if you take a look at your circle 2D v4.csv, you'll also notice that you now have 10 rows. So hopefully you have found this video useful. As always, if you have any questions, comments, or concerns, don't hesitate to reach out to me. And thank you for watching.